break there, I had a little glitch there because this machine has two adapters. And earlier, I disabled the TH0, I was using only TH1. But when you restart network service or when you reboot the machine, it also starts the other adapter. So that's why I was still, because my other adapter is a 200 range. That's why I was still pinging. But so I need to disable the TH0. I'm using only TH1 on this machine. So as it is now, see when I'm on the client CentOS machine. If I do ifconfig, you see my both adapters are active right now. So I will disable it at 0. You don't need two adapters on the client. I just happen to have two on this one, so I'm using only one. So I'll do if down ETH1. I'm sorry, ETH0, right. I've done ETH0, and I have up ETH1. So here we go. I have only ETH1 running right now at 200 range, exactly like in my diagram. So as it is now, if I do route to display my current routing table, I don't have anything about how to reach the 100 network, where the Windows machine is located. So I'll create a static route. It's in the memory of in the history of my commands here. Okay. In fact, as it is now, I should not be able to ping the Windows 10 machine. I cannot ping it. So I'll add the static route. As a result, when I do route again, now I see that static route has been added here with the gateway information. And now when I ping, it works. So this is a recap from what I did before the break. Nothing new. I just did it fast now so that we're on the right track again. And we'll see now logically step by step what I'll do next. Any questions? Now, next point actually, what if I want to delete the static route? It's simple. If I want to remove it, it's a similar command. Instead of putting route add, IP route add, you put IP route del to delete. So now, see it's gone from my table, it's no longer there, and ping should fail again. So I'll put the route back, add instead of delete. So it's back in the table, and ping will work once again. So you know how to create and delete static routes. But here's where now let's see if this route is persistent or not. So what I'll do, I'll restart network service. It's just what I forgot to do before breaking after restarting the service. I have to disable ETH0 again because I'm using only ETH1. And when you restart network service, it brings up both adapters. So since I want to use only ETH1 on this machine, I will just disable again my ETH0. So I have down ETH0. But my ETH1 is still running, of course. So if I check the table now, you see, the static route is gone. It's not persistent as it is. And therefore, I will not be able to ping the Windows machine. So, to make a long story short, when you tap these static routes using these commands here, it creates a temporary static route. It is not persistent. If you reboot the machine or if you reinitialize network service, it will delete the static routes. You may try rebooting as well. I will not spend time in the lecture doing it now, but if I were to reboot the machine at this point, and of course, again, I would afterwards bring down my other adapter, then it won't be able to ping the Windows machine. Any questions up to this point? So now let's show how to make a persistent route on CentOS. You go persistent route. We'll check it. We'll do it in Windows afterwards as well. For now, I'm doing it in CentOS. So to make a route persistent, here's what I'll do. First, I will again delete this temporary route. Actually, it's already deleted because I restarted my network service. So there are no routes now. The table is not showing any route to the 100 network. So to make a persistent route, you go to this directory where I am right now, and you create a new file. See, these are the files I have right now. So I create a new file called route-eth0 text file. So you save your static route in this file. And you save it in this directory. So nano route-eth0 . Now what to type in this file? Here's the syntax. Uppercase, I'll type in and I explain. IP address 0. Then net mask 0. And gateway 0. So this will be the IP of the router, which is 200.2. So basically, this is the info I have in my static route, right? To specify the network ID of the destination network, the mask in the static route was written /24, and the gateway's IP. So you type the information in this file in 3 lines. Now, why is 0? I'll explain that later, one step at a time. For now, just take note of the syntax. Okay. So I'll save the file. So now I have it in my directory, route it at 0. And of course, when you make a change to directory, you need to restart network service. Now, before I restart, actually, let's check again the table. If I just tap route now, see, there's no line about the 100 network. I'll restart a service. Let's check the table again. So now we see that. Oh, just a second. Yeah, I will do. This line came again because of my ETH0 being enabled. But otherwise, okay, let me just check my file again. Probably there's a little syntax error in the file. Yeah, I think, yeah, there's no IP, just address 0 there. There should be no IP there. It's my mistake. I should have IP there, okay? It's address 0. All right, so in the end, I'll give you a chance again to take notes of this once I finish demonstrating it. So I'll restart the network service again. All right, the best thing to do, because it looks like there's one little detail which is not correctly done in my syntax. We'll check it online. So I'll tap CentOS 7. It's not something I do every day, so what I'll do, CentOS 7 persistent route, or simply I'll tap route ETH0 file. Oh, I just realized something actually. I'm using the ETH1 in my client. I should have put ETH1. But anyway, but let's double check the syntax anyway. Yeah, my syntax was perfect. It's just that I'm using the ETH1, the adapter there, so I should have put route ETH1. That's the problem. So I'll delete the existing file or simply rename it to route ETH1. How to rename a file? Move route ETH0 to a route ETH1. Because I'm using the ETH1 adapter on this client machine. So I'll restart the service again. Much better now, it was fast. And now let's check the table. I'll bring down the ETH0 adapter. Still not showing my static route. It's a strange problem. I mean, sorry for it. We'll fix it very soon there. But this was supposed to show the line for the static route here. Let's check the file again. Right, we'll check it once again online. If anybody sees a syntax error compared to the website, let me know there. I have the IP of the target, gateway 0. Looks okay here. Sorry. Okay. So I'll do IF10 IFF for ETH1. All right, now it works. It was just a delay or something. All right, so let's recap. I know maybe it was confusing because, but now I'll recap the whole thing and everything should be clear. Now everything is fine here. All right. I'll take it once again from square zero so that nobody will be confused, okay? Please follow well. Now everything is working. So what I'll do, first I'll remove the file from its directory. So instead of square 0, I'll move the file out of this directory. mv route eth1, sorry. I'll move it to my test directory somewhere. Test directory, I think. Right, so it's gone. It's in a test directory now. All right, there was no test directory actually, so okay. All right, I'll create a file again afterwards. So now I don't have route eth0, eth1 in this directory. So I'll restart my service. So what's the situation now? When I check my table, there's nothing about a route to lead to the 100 network. In fact, this is because of my other adapter. So I'll bring it down. So as it is now, there's nothing about the 100 network. And therefore, I should not be able to ping the Windows 10 machine. So now I like to create a persistent route. And on this client machine, I'm using my ETH1 adapter. So in this directory, I create the file route ETH1. And I type 3 lines in it, uppercase, address 0, the IP of the network I want to reach, which is the 100 network, then net mask 0, the class C mask, and the IP of the gateway, that's gateway 0, and that's the IP of the router I need to point to, which is here, 200.2. Okay? So at this stage, in order to avoid confusion, the best thing to do is simply to do IF down, IF up for this adapter. So IF down ETH1 and IF up ETH1. And now when I check the table again, I see that the static route has been added here with the IP of the gateway. And this is now a persistent route because it is saved in the file. So of course I should be able to ping now the Windows machine. But now, even if I restart my network service, the route should not disappear. So if I do route again, see it's still there, the route. And even if I will bring anyway the ETH0 adapter down. See, my route is there because it's persistent, and I should still be able to ping the Windows machine. So I'm going to proceed now. Any problems, any questions? I'll recap quickly now, but are there any questions at this point? If you restart the computer, you mean, it will still be there. The route is persistent because it is saved in a file. Unless you delete the contents or if you delete the file there, it will always be there. You don't need to put in a logon script, that's not the point. It is saved, the file has to be saved in this directory, the network configuration directory. You see what I mean? This directory here where we have network configuration files, that's exactly where you save the file. So as long as you leave the file here with the proper syntax, the route will always be there. Even if you reboot, even if you restart network service, it doesn't matter. So now, let's recap. As I'll go many commands backwards. All right. So what does this command do? I'm just recapping on the main ideas. So what does this command do? This command creates a temporary static route. It works, it adds the route and you're able to ping the destination, but it is temporary. If you reboot the machine or if you restart the network service, it will delete this route. Next idea. We're getting there. All right, I should have, sorry, I know what happened. All right, so we said this as a static route. If I replace ADD by del, what does this do? Obviously, this is just to delete an existing static route without, even though it's temporary, but if you delete it this way, even if you don't restart network service, it will delete the route. So add this to add a temporary static route. Del delete is to delete a temporary static route. So if you want to make the route persistent, what do? You create this file, route ETH1, or you see, it could be route ETH0 if you're using the ETH0 adapter. In my case, I've been using the ETH1 adapter on this client machine. So you just put the name of the adapter that you're using on this client. So you create a file, route ETH1, and that's the syntax you put in it. And these are in fact the components of the static route. This is the IP of the destination network, the mask, and the gateway, the IP of the router to provide the connectivity. After you create and edit this file, you just do IF down and IF up for the adapter you're using, in my case ETH1. And then this will provide a persistent route. As long as you don't delete or modify this file, the route will stay there no matter what you do. I hope it's clear at this point. If you have any questions, go ahead. Now, why in the C syntax you have 0 here? What's the meaning of the 0? The point is that in this file, you may add many static routes. Let's say I want to make another static route to tell this machine how to ping another destination. Then you go to another section here, and you type similar 3 lines. Now this time, you put 1 instead of 0 everywhere. So this number is simply to distinguish between different static routes. And of course, this will be another network. Let's say this, in this case, you want to reach the 150 network. And the gateway may or may not be the same. Maybe it's a different gateway this time. So you may have as many as you wish. They'll always all be saved in the same file here for the ETH1 adapter. All right, any questions on this one? So I just put this for explanation. I don't need to save this because I'm not using 150 network, but that's the reason why you have 0 here, to identify this first static route. So now, let's also review how to do this on Windows. Typing static route and then a persistent route as well. So at this point, the Windows machine is using still default gateway. By the way, they don't have to be the same technique, right? See, one client can use a default gateway, another client can use static route. It doesn't matter. So now I'll go to the Windows machine. So I'll first remove the default gateway. As it is now, of course, can ping the CentOS client there. But I'll first remove the default gateway. So now, if I try to ping again, I can't. And now I'll create a static route on Windows. It's the same technique, it's just syntax a little bit different. So with our static route, instead of IP route add, you just type route add here. Uppercase to see it better. Route add. Then the destination network's IP address, which is now 200.0. See, now the client is in 100 network trying to reach the 200 network. It will use this gateway here, 100.2. So destination network is this. Here you also type mask before typing the mask. And then you don't type via, you just put the IP of the gateway. And that's 100.2. So check the table in Windows, you type route print. See, right now there are no persistent routes, but because of the command I just typed, there is a line now for the 200 network with the appropriate gateway. So this is the route I just entered. So as a result, when I try to ping now the Windows, the Linux client there, it works again, because then it gets it from the static route, even though the machine no longer has a default gateway. Are you okay with this one? Now, is this persistent? As we have seen, no, but let's verify it as well. I will restart the adapter. To do it in Windows, I'll go to Control Panel again, and then here on the network configuration page here, you just click on Change Adapter Settings, and disable and re-enable my adapter. Is equivalent to restarting the service in Linux. Now if I look at the table again, see, I don't see that line with 200.0. It disappeared. And therefore, ping will also fail. So you can see that the route was not persistent. So this command adds only temporary route. Now, how do we make it persistent in Windows? It's a bit easier. You don't have to create a file. You just repeat the command by putting the -p option to make it persistent. As a result of this, let's check the table again. So now it's been added to the persistent route section here. Also here, but more specifically, it is now the persistent route section. And ping should of course work. And even if I restart the adapter in control panel, I can still ping. And the table still displays the persistent route. And now both clients, Windows and CentOS, have persistent routes. Now in Windows, how come we don't need to create a file? How does the -p option work exactly? It's because it saves it in the Windows registry. Now we're not doing a course on Windows here. I will not go into the registry and show it, but just to mention it, maybe you have seen it before, or if you don't remember, just you can go online and check where in the registry it is saved on Windows. But that's the answer. It is saved in the Windows registry. No questions? It's okay. So you see how to create persistent routes and static routes, temporary or persistent, in both operating systems. Have you taken note of the steps in Linux more specifically? If you missed anything, let me know. Just to make sure, because there were a few problems earlier, I'll quickly show the steps again without executing them, just remind you of the commands. So in Linux here, here's again a command to create a static route, a temporary one. So now I'll show both operating systems in parallel. We're getting there. All right. So this is in CentOS, and at the same time, if you look at Windows there, this is the route add command in Windows, and the corresponding command in CentOS there. They do the exact same thing, which is to create a temporary static route. Just that there are minor syntax differences there. So make sure you know on both operating systems how to do it. Now, these are again temporary ones. If you restart network service there, or if you reboot the machine, these routes will disappear. So to make it persistent, in Windows, you just repeat the command by putting -p. In CentOS, what do? There's no -P option there, but you go to the network configuration directory where I am right now. And you create the file route hyphen the name of the adapter that you're using. In my case, ETH1. If you're using ETH0, it'll be route ETH0. And you just type the right syntax in the file, which I will show again. There's 3 lines. Give the same info as the static route. It is a static route saved in a file. Once you create and save this file, then you do if down ETH1, like your adapter, and if up. So just bring down and up the adapter in particular for which you have created the file, and you'll have a persistent route available. Now, all this work has been lately on the client machines, right? In all cases, the router must be available with IP forwarding enabled. Don't forget about that. I remember in the past, a student asked me the question, if I use static route, do I still need IP forwarding to be enabled on the router? Of course. If there's no IP forwarding on the router, nothing will work. Okay? So at all times, for the clients to be able to use the router, you must have IP forwarding enabled on the router. All right, any questions at this point? So if there are no questions, I have enough time in this lecture to do one more interesting step. I will not do routing with IPv6 today. We'll leave that for next week. But I'll do something else, which is about related routing. So now that we have set up with routing, let's think of DNS. I will add my DNS server in this diagram. And the IP of my DNS server is in 100 range. I'll type it. So my DNS server is in the same network as this Windows client, but now my CentOS client is in a different network, 200. And for a DNS server to participate in this network, I will also provide the gateway information on it, either through static route or through default gateway. So let me make sure that that's done. I'll go on DNS server. So let's check if there's default gateway here. By the way, how do we check? See, that's another thing I didn't show, but let's do it now. In Windows, to see if you have a default gateway, there's a very simple thing. You don't need to go to control panel. You can just have ipconfig. If you have ipconfig in Windows, it shows you the default gateway, if any. Right now, there's a default gateway on this one because I'm using static route instead. But it will show it here. When you do ifconfig in Linux there, it does not show default gateway. However, you can see it by typing the route command. See, this one does have already a default gateway. And we can, of course, verify it also through the network configuration file. Sysconfig. So the gateway is already set, pointing to the right IP here, 100.2. This DNS server, I should be able to ping the clients, for example, the CentOS client, which is in the 200 network. I can ping it. And likewise, the CentOS client should be able to ping this DNS server. And of course, the Windows client being in the same network as the DNS server should be able to ping it as well. Great. So now I'd like these clients to be able to use the DNS server for its main function, which is host name to IP resolution. So let's check. I'll start with the Windows client, which is the same network as the DNS server. And let's look up any of the zones. Let's say get www.soccer.net. It works, it gives the IP 251. If I try this on the CentOS client, of course, we have also to make sure we're pointing to the right DNS servers, right? Let's not take it for granted. So on the Windows machine, yeah, actually, this is a slave server it's pointing to, but I'll put the 27 so that we don't get confused. So this is the Windows machine pointing now to 100.27. Here I'll flush DNS and do it again. And now NS lookup again. So it works. Now I'll go to the CentOS client. I'll check the result.conf file. It is pointing to the same DNS server. It's on a different network, but no problem, as long as I have a gateway, and that's why I checked that they can ping each other, so it's available. This client can reach this DNS server. So now, if I do an lookup, it also works. But let's look at this a bit in more detail now. Does it always work like this? Okay, from both clients. This will take us back to something we have seen previously, but now we can experience it firsthand. I'll go on the DNS server and check my namely.conf file. In the internal section, I have soccer.net. In the external section, I also have soccer.net. When I look at this, in the external section, I don't have college.org. Here I have college.org, right? In the internal section, I have college.org. In the external section, I don't have it. Now, what records do I have in college.org? Let's check it in var named. So for example, it may be ftp.college.org. That should resolve to 70. No, to 60, sorry. FTP is an alias for hockey, and that's 60. So let's check this one. Back to the Windows machine. And let's look up ftp.college.org. It works. If I go on the CentOS client, it doesn't work. So what's the explanation? I think it's obvious here, but I hope everybody's following there. Why it doesn't work for the CentOS client? What should I do for it to work for CentOS client? Yes, entries in external. So now we see exactly what those sections are for. College.org is not working for the CentOS client because the external section does not have any reference to college.org in namely.conf. So here is now the scenario where this client is an external client. It's in a network which is different than the DNS server's network. So it needs those records to be available in the external section. For the Windows machine, there's no issue here because it is in the same network as the DNS server, and therefore the internal section is what it is using. So back to my DNS server then, namely.conf. So the internal section does have college.org. That's why the Windows client is getting it. And I'll just copy it to the external section. And don't mess up with the brackets. The last bracket is to close the external section itself. So you insert this before the last bracket. Or actually, to make it even more neat, I will put it before the reverse lookup zone. Here we go. So I'll restart my named service here. So back to the CentOS client. So now it works right away because it's getting it now from the external section of the DNS server. For Windows client, nothing has changed because I left it intact in the internal section. If I were to remove that zone from the internal section, then Windows will fail. Try it now. I don't have time to try every possibility here in the lecture, but very simple to try. If you go back to name.conf there, and in the internal section, if you put square signs for college.org to disable it, in order to delete it, just put square signs on all 4 lines. And then restart your service, and at that time, the Windows machine will no longer be able to do this DNS lookup. Just that I recommend on Windows to do also flashing before you try again. Flash the cache, ipconfig flash DNS. It is a good demonstration of what those internet external sections are for in DNS. So I'm pretty much done with this lecture for today. I'll just remind you what lab work to do. I'll also give you a chance to ask questions if any. So some interesting lab work for today. Now, yesterday some of you probably finished the previous lab report because I gave that extension with a bit of penalty on the marks there. But hopefully many of you already finished yesterday's lab on master slave, forwarder, and reverse lookup zones. If not, that's where you have to start today. If you haven't done them yet, catch up with the DNS, very important practice, reverse lookup, master slave, and forwarder. That was yesterday's lecture. Also, IPv6 records for DNS. Host records. So all this was done yesterday. We have the research paper which you have to submit by June 11th. And today's new material then, very important to practice as soon as possible. Initially this morning we did host file versus DNS. You have the summary here. Make sure you know how to use the host file. And the new idea we have seen here is that if there is a conflict, contradiction between DNS and host file, then the host file will prevail. So you will try to ping the IP given by the host file, not the one given by DNS. Later in the semester, we'll see more about this. Then we did routing with IPv4. So first, the basic default gateway technique. First, of course, how to set up the router with IP forwarding and two adapters, and then using default gateway of the clients so they could ping each other. I gave the little example of creating a script on the router so that if you initialize network service on the router or if you reboot it, you can just run the script to make sure that IP forwarding will stay enabled. Then static routing in both Windows and Linux. And we have done both the temporary option and persistent option. So in Linux, I put routing2 or could be routing2 depending on the adapter you're using. So or routing2. In my case, it was routing2. And in the end, I also added a DNS server. So DNS in routed network. And you have to review namely.conf. And the idea is that the internal section helps the clients in the same network as DNS, while the external section is for clients which are in the other network. So internal versus external sections. So all these things are important to practice, guys. There's a lab test in the end. Any of the things that we're doing now could be and probably will be part of the lab test. This is time to practice them. Next week we'll be doing other things. When we meet on Saturday, in 6 days actually, I will finish routing by doing IPv6 routing, and then we'll move on to the next subject, which is DHCP. And it'll be another lab report, and I'll assign it next weekend. So don't fall behind. Practice everything that we have done as much as you can today. Any questions before I finish the lecture? You'll get this updated file, of course, and also a diagram for routing. So next weekend we'll do routing with IPv6, DHCP with a large setup, and on Sunday next week we'll probably have time to also start the next discussion on practice, which is Samba, parent-printer sharing. We still have many things to do in this module. That's why I'm urging you not to fall behind. If you only do a lab report and nothing else there, it's only a small part of the lab practice. The lab test will cover everything that we do in the module. All right, I would like to see any review of any configuration I did today. You missed anything, any questions? when you use the DNS there in the end, don't forget that the DNS server also has to point to the gateway, either through static route or through default gateway. Because if you don't do that, clients will not be able, the second client, which is in a different network there, will not be able to reach the DNS server, will not be able to ping it. So in other words, once you have routing here, all the computers in your network, clients, DNS, everything, should point to the router one way or the other, either using a default gateway or static route. All right, then if you don't have any questions, the lecture time is over. The few of you send me questions about your marks. As I said yesterday, I'll reply to you during the week, on weekdays. I'll check. I didn't even check it. I'll see what your request is exactly, and I'll reply to you.